Find the area enclosed by the curve y is equal to the square root of 16 minus 9x and the axis as shown in the diagram. So here we got the curve y is equal to the square root of 16 minus 9x, and we've got to find this area here, which is enclosed by the curve, the y-axis and the x-axis. So what we need to do is either we can find the area between the curve and the x-axis. However, in this case, it's actually easier to find the area between the curve and the y-axis. So let's just see how we would do that. So this point is 0, so we need to find this point here because this will be the upper limit of the integration that we need to do. So if we say that y is equal to 16 minus 9 times 0, because the x-coordinate of P is going to be 0, then y will be equal to the square root of 16, which is 4. So this point is 0, 4. Now, the area, if we're going to find the area between the curve and the y-axis, then it's going to be the integral from c to d, of x dy. But we got this written as y is equal to the square root of 16 minus 9x. So we need to rearrange it to make x the subject. So we've got y is equal to the square root of 16 minus 9x. Squaring both sides, we get that y squared is equal to 16 minus 9x. 9x will be equal to 16 minus y squared. And then x will be equal to 16 minus y squared over 9. Right, so using this idea that the area is equal to the integral of from c to d of x dy by dx, and all we now have x is 16 minus y squared over 9. Now to deal with the 9, we can take it actually out of the integral sign, so it will be 1/9, because this is over 9, times the integral from 0, which is the lower limit, to the upper limit, which is 4, of my function 16 minus y squared. But don't forget to put the dy in. So when you're doing this type of question, you have to set up the integral correctly. Right, we can now integrate with respect to y. So it's going to be 1/9. So the integral of 16 will be 16y, and this will be minus y cubed over 3. Now the limits of integration now come down here, so that'll be 0, and up here we now put 4. So using the correct notation all the way throughout, then we substitute 4 in, so it's 1/9 of 16 times 4 minus 1/3 of 4 cubed minus 0. Now you should always check when you put 0 in here that it does actually give 0. So be particularly careful if it's something like cos, for example, or e to the x, that would not give you 0. But in this case, when we do substitute 0 on, this bit will become 0. Then if we take our calculator out and make sure we are using the fraction button, that will be give me 128 over 27 square units, or 4.74 square units. So this has been a video to show you how to find the area of a curve enclosed by its axis by finding the area between the curve and the y-axis. I hope you've understood, and I thank you very much for watching.